Okay, today we're going to continue talking about object-oriented programming in Java with a concept that I think seems more complicated than it is. And it's one of these things that maybe seems complicated because when you first learn it in Java, you're not sure why it would be useful until the first time you're designing a program and you realize, oh, this would actually be a useful way to do this. And the concept or the idea is called abstract classes. Let's think about a simple program where we've got a class with subclasses. Let's say we've got a class that is animal and subclasses that are cat and dog. Let's imagine we're writing the code to keep the records at a veterinarian office. And for each animal in the record system, we need to know whether it's a cat or a dog or whatever. It doesn't need to be for anything, but just imagine that that's what we want. So cats and dogs are both kinds of animals, and you could have all sorts of other animals that might come into the vet's office, right? You might have a snake or a lizard or a guinea pig or whatever. So all of these animals are subclasses of the class animal. But you would never have something in the system that's just an animal. An animal is a category of things. No one would come to the vet with something and here's my animal that I brought to the vet, right? So that's not, you would never want to create an instance that was just of the animal superclass. And to guard against the possibility of that even happening, Java has something called an abstract class. An abstract class is one that exists as a structural component of the program, in that dogs and cats and lizards and guinea pigs can all be subclasses of this abstract class, meaning they can inherit instance variables and methods from that class. But the fact that it's an abstract class means you can't actually create an instance of an animal in your program. Animal is just an organizational part of the program. It's just to give a container for the cats and dogs and guinea pigs and what have you. So let's think of some things that animals do that could be methods of this class. Animals can sleep. So we'll have a method of the animal class called sleep. I should probably indent that. And for now, it will just print out just little sleeping noises. I could have an abstract, a method that is make sound. Public void make sound. Right? Most animals make some kind of sound. But what kind of sound does an animal make? Well, an animal doesn't make any particular sound. It depends on what kind of animal it is. All animals sleep, so I can have a generic sleep method with this abstract class that all the other animal subclasses can inherit. But I can't have a specific sound that a generic animal makes. So I don't want to ever call this make sound method of the animal superclass, so I can make that method abstract as well. Okay? So the abstract method, make sound, is just a sort of empty shell with no body. I could never call it, and there's no reason to call it, because it doesn't really mean anything. It doesn't mean anything to tell an animal to make a sound unless you know what kind of animal it is. There's no generic sound made by animals. So we can have abstract classes and we can have abstract methods in those classes. And the difference, again, between a regular method and an abstract method is that an abstract class helps you organize your subclasses. It helps you implement polymorphism in your code. In other words, it helps you have a make sound method that all of the animals will have, all of the different animals will have. But you can't create just an animal. You can't create an instance of that abstract class, and you can't call the abstract method of that class. It is just there as a structural placeholder that enables the polymorphism, that enables your various animal subclasses. Okay, so we have the abstract class animal, which has one abstract method called makeSound, which doesn't do anything. There's nothing in here. It just ends with a semicolon. And then a regular ordinary method called sleep that could be called, and the subclasses can actually just inherit. Okay. So we want to create a cat that is a subclass of animal. It's exactly the same syntax. Class cat extends animal. The only thing that's different is it's extending an abstract class. We're going to have a makeSound method of the cat class. What that will look like is no arguments. There's my start bracket. There's my end bracket. I have a hard time seeing my keyboard with these lights right now. So this is the makeSound method of the cat subclass of the animal abstract class. We can do the same thing for dog. I'm going to copy all the same stuff. Class dog extends animal. We have a makeSound method. It's going to say the dog goes woof, woof, exclamation, end quote, end parentheses, semicolon. Okay, and then I need to end that method with a curly brace. Oops. End the method with a curly brace. And then that curly brace ends the dog subclass. Okay. I will just leave the sleep method as it is. So dogs and cats, when they sleep, they don't do anything particularly different from one another. So both those subclasses can just inherit the sleep class from the superclass. Even though the superclass is abstract, you can still inherit its methods. You just can't make an animal. Okay? So here's my main program. We need to do this right syntax-wise. So let's write this like a real main program. We got to do public static void main blah, 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 blah. Let's create a new instance of a cat. The variable is called Percy. It is a cat. It is a new instance of the cat class. Let's create a dog. Okay. Hazel is the name of a new dog, which is a member of the dog class. And then let's call their methods. We'll tell the cat, whose name is Percy, to make a sound, and then sleep. And we'll tell the dog, whose variable name is Hazel, to make a sound and then sleep. Let's put some empty print lines in between those. Just to make our output easier to read. Like so. Let's run and see if we made any mistakes. Oh, invalid method. Oh, did I just forget to type? Oh, I just spelled abstract wrong. Yeah, that don't work. Abstract. Where is it? That's a weird error. I just spelled abstract wrong in my one. And then I'm missing a end Java 49. This ends the class. I need an end of my main program. Just copy and paste, and I missed a couple of curly brackets. No? Oh, see, this is what happens when I'm not careful with my curly braces. This is the class. I guess I'm missing a curly brace that ends the sleep method here. Okay, this is ends method. This is ends class. I probably did that more than once. Right? This ends the method, this ends the class, this ends the method, this ends the class. Okay, there we go. Just needed to count up our curly braces. No big deal. So the cat makes its sound. That says meow. Then the cat sleeps. Little sleepy noises. The dog makes its sound. Woof woof. The dog sleeps. Notice I cannot create. I created a cat. I created a dog. Let's try to create an animal. Animal. I need a name for it. XXX equals new animal. If I try to create an animal, I should get an error just telling me that I can't do that because animal is an abstract class. Line 41, error. Animal is abstract, cannot be instantiated. So I cannot make an animal. I can only make cats and dogs and guinea pigs and snakes and whatever kinds of subclasses I want to make. Okay? So you can think of abstract classes as just a box to put subclasses in. It doesn't do anything by itself. You can't make one. You can't call it. But the usefulness of it is it allows subclasses to inherit methods and instance variables from something, even though that something is not something you would ever create an instance of. I think one of the first programs we wrote when talking about classes was about vehicles, right? You can have cars and trucks and motorcycles and bicycles and airplanes and helicopters and boats. Those are all vehicles. You might want to create objects that are of the class boat, truck, car, bicycle. You would never create something called a vehicle. A vehicle is too generic an object to create a generic version of. So in a program where you were keeping an inventory of vehicles, you might have an abstract class that was vehicle, and then subclasses that extend that abstract class: car, truck, bicycle, motorcycle, jet ski, whatever. Okay. So that's a pretty simple idea, I think. The implementation of it is the single word, abstract, that you put before your class definition if you want that class to be abstract, and that you put before your method definition if you want that method to be abstract. Here is something important when you are doing abstract classes and methods. Let's get rid of that animal. He can't exist. Let's run this and make sure it works. Suppose I did not create a make sound method for dog. Okay. Now there is a make sound method for animal, but it's abstract. Let me try to run the program now. Error. Dog is not abstract and does not override the abstract method make sound in animal. What does that mean? That means if you have an abstract class and that class has an abstract method, all of your subclasses have to have a method that overrides that abstract method. Otherwise, Java doesn't know what to tell them to do. Okay? Because the abstract method doesn't do anything. It's just a placeholder. All of your subclasses have to override that placeholder. So if you've got an abstract class called makeSound, every subclass has to have a makeSound class that overrides that generic abstract method. Okay? So that's a conscious choice you have to make. Yes, all the animals are going to make a sound, so I want that abstract method in here. But once you do that, it's not an option to then have a class that doesn't make a sound. If you've got some animal that doesn't make a sound, a turtle, turtle, extends animal, you can't just leave the make sound method out of the turtle. Error, turtle is not abstract and does not override the abstract method make sound in animal class. You gotta have that method in there because it extends an abstract class that has that abstract method. Now, what do you make your make sound method do for a turtle? You could just have it say, the turtle is quiet. Okay? But there has to be something there. Right? If you've got an abstract method, every subclass has to override it. Every subclass has to have its own implementation of that method. Otherwise, Java's confused because that abstract method can't do anything. It's just an empty placeholder. Every subclass has to have some implementation of that to override the generic one that doesn't do anything. Okay? I'm going to leave it there. That was really quick. That's like 15 minutes. I might just ask you to answer some simple questions about abstract classes. I don't think I'm going to make you do your own code with an abstract class. Instead, what we'll do in our next video is we'll look at another example of abstraction in Java, and then maybe the next assignment after that we can come up with some code that implements both those things.